So first we got there in the expression 3 to the second power, the 2, that little 2 up there, that is called a blank. So we've got that for me. What do we call that little 2 up there? Morgan? Exponent, perfect. So that would be our exponent. Let's see how I can write it. Make that really slow. Okay. True or false? 5 to the 4th power is going to mean 5 plus 5 plus 5 plus 5. What do you think? True or false? When you have 5 to the 4th power, does that mean to add 5 4 times? Correct. So this one we're going to say is false. So you should be multiplying that. Thank you. And lastly, evaluate. N times n times n times n. So evaluate's a word that we talked about in our last couple lessons. Evaluate just means to solve. So we're going to take the variable out, put the number in, and then solve it out. So we're going to look at taking -3 times another -3 times another -3. You guys are kind of my guinea pigs with this, so there we go. So you have -3 times -3. So if we use our properties of negatives, what's going to happen when we multiply 2 of those negatives? -3 times -3. What are those two going to make? Positive. Positive. So we're going to get -3 times -3. We just multiply the 3s. That's going to give us a positive 9. And then those last two -3s, they're going to also make positive 9. So basically now we just have 9 times 9, which is positive 81. And there it is. So positive 81 would be our result. So each day you'll have a little warm up on our lesson instruction videos. I did cut that out, but if you want to do that little part on your own, just kind of check where you're at. You can. I cut that out of the videos because I wanted to make those instruction videos a little shorter for you. All right, let's head down and take a look then at negative. Did I do that for you guys? Did I put definitions on those notes? All right, so you guys already got that. So first, exponent. So exponent tells the number of times that a base is going to be multiplied out. So that's something you've been introduced to, just kind of a review there. So we looked at that second warm-up, 5 to the 4th power doesn't mean you add 5 4 times. We're going to multiply that base 4 times. Negative exponents. When you have an x to the negative n, that is equivalent to 1 over x to the n. It's called a reciprocal. So when you have a negative up in your exponent, it's going to make the power its reciprocal, which we're going to take and go 1 over that power x to the n. Anytime we are going to simplify powers, anytime we have to do that, we have to write them with positive exponents. So any negative exponent, we're always going to rewrite it as its reciprocal. So we'll talk about that in just a second. So first you have x to the negative n, that definition, that's going to be equivalent to 1 over x to the n. Or if you had this 1 over x to the negative n, that's equivalent to just simply x to the n. So if you do have a negative exponent in your denominator, that's going to revert up to the numerator. If you have a negative exponent in your power, that's going to put that power down into its denominator. So basically just flips from numerator to denominator anytime you have a negative exponent. So in that first one, that's what we're seeing there. We got a 1 over 5 to the negative 2. So right now I have a negative exponent in my denominator. And what that negative exponent does is it flips. So now instead of the denominator, where is that power going to go? Up top. What do we call that up top? Denominator is the bottom. What's the top? Called Morgan. The numerator. So that 5 to the second is going to go into the numerator. So it's going to make the reciprocal. So basically what's going to happen is this is going to become 5 to the second over 1. So it's just going to make that reciprocal. Then 5 to the second power, we all know what that is. 5 times 5 is 25. So there's what that first one simplifies to. Continuing, you have a 5 to the negative 2. So right now we have a 5 to the negative 2. So right now I'm thinking of that power. If it was a fraction, it'd be 5 to the negative 2 over 1. So right now the 5 to the negative 2 is in the numerator, and that negative exponent's going to make it the reciprocal again. So it's in the numerator to start. Where is it going to end up? So right now that negative is in the numerator. It's going to drop to the bottom, which we call what? It's going to go down to the denominator. So then I'm going to have the reciprocal there, and that's going to make then 1 over 5 to the second, which is 1/25. So there would be my result there. So far I've got a 1 over 5 to the negative 2 is equivalent to 25. And 5 to the negative 2 makes that 5 squared go down into the denominator, and that's going to give me 1/25. Now the last one that we're going to look at from this section is when you have a negative sign up front. I'm going to rewrite that because it's kind of hard to see it there. Your printout shows it pretty well, but you have a negative 5 and then a negative 2. So we have to go back and talk about order of operations. As you go through order of operations, what's the very first thing you do in order of operations? Please excuse my dear Aunt Sally. What's that very first thing?
Parentheses.
The parentheses. We don't have parentheses on this one, but that second thing, what's always the second thing that we do? After parentheses. Exponents. So the very first thing that we're going to do whenever we're working through with numbers and trying to simplify is we're going to do the exponent piece. So here we have an exponent that's negative 2. But that negative sign out in front, that is like a negative 1 that is multiplying my power. So I'm not going to worry about that because when do we do multiplication? We do that later. So we're not going to worry about that multiplication right now. We're only going to worry about what that power is doing. So I'm only working on this part that I've circled, this 5 to the negative 2. That's the only thing that I'm worried about. Now we've already done 5 to the negative 2. What happens when we do 5 to the negative 2 power? We get 1/25. So that red piece that we circled, that ends up being 1/25. And that negative sign tags along, so we get negative 1/25 for our result. So I have to do that exponent part first. After I do the exponent part, then I can go back and do any of the other order of operations I need to, so that negative would come along then with that at the end. So that would be a couple examples with those negative exponents. In the essence of time, those are just kind of the same problems over and over. With that negative exponent, it's going to take your power and it's going to flip it either from the denominator up to the numerator, or it's going to take the numerator and flip it down into the denominator. So it's going to flip it either way. So negative exponents are also referred to as reciprocal. You guys heard that word reciprocal before? Or the numerator denominator flip? That's what those negative exponents do. They flip those powers between the numerator and the denominator. All right, continuing, we're going to take a look then at a couple of power rules to finish up here. So these should be review from Algebra 1 topics that you've discussed in the past. So first is the product rule. Product means multiply. And the product rule for exponents is if you multiply two powers with the exact same base, you can add their exponents together. So x to the m times x to the n is equivalent to x to the m plus n. So you can add those two together. When you're dividing two powers with the same base, you can subtract their exponents. When you have two powers that are being divided, any common bases are going to cancel out, which is we're going to use subtraction to represent that. So down below here, we're going to use these two rules for exponents to start simplifying our little power examples there. So first we have part A, and I'm going to use color coding. If you have different colored markers, it helps, or pens, excuse me. That's going to help kind of keep things organized. So first thing I'm going to do is I'm going to rewrite my part A. I'm going to rewrite it with all my x powers together, and then all of my y powers together. I'm going to put those together here to start out in part A here. So I have an x squared that I see in there, so I'm going to rewrite that as x squared. I'm going to use red to represent my x's. So there's x squared. Then after that x squared, I got a y, but then I'll have an x to the negative 3. And then I've got an x to the negative 5. And we talked about properties of algebra the last couple days. Which property says I can change the order of the stuff I'm multiplying? Which property says if I do 3 times 4, it's the same as 4 times 3? I can change that order. It starts with a C. You guys remember it? Commutative properties. So anytime, if I have a bunch of stuff being multiplied together, I can decide how I want to multiply. It doesn't matter. I can go any order I want. So I'm going to put all the x's together. Because then I can start looking at this product rule. I can say, hey, if I got the same base, if I got all these x's, I got the exact same bases, now I can start to add their exponents because they're the same. That's going to start to simplify things up. Next, I'm going to do the y's in blue. So in blue here, we'll get our y's. We got a y to the negative 4. Then we've got a y squared. And we've got a y plane. And then we've got a y to the negative 2. And looking through, I'm just going to double check. I've got an x power, x power, x power. So 3 x powers, y, y, y. I got 4 y powers. So there's all my powers rewritten using the commutative properties. I get all those x's together, all those y's together. Now we're down to using the product rule. So I'm multiplying the exact same x powers together. Well, what could I do with the exponents? I can add them. So it comes down to just some basic arithmetic. So if you have 2 and then you add negative 3, that's going to bring you down. What is 2 negative 3 going to give you total? Negative what? Negative 1. And then you take 5 more away. So negative 1 goes down to what? Negative 6. So I'm running out of room below, so I'm going to put this above. But your x's then, all your x's are going to add up to x to the negative 6. And then you do your y's. Now I'm seeing something nice. If I have a plus 2 and a minus 2, what's going to happen with those two y's? That's going to be gone. That one's going to be gone. Because 2 plus negative 2, what's it going to equal? 0. Boom, gone. So now I just got this y to the negative 4 and a y. Well, y is not with a power right now, but if we did have a power, it would be a 1. So now we're going to add negative 4 and 1 together, which gives us y to the negative 3. So the total that we're going to get when we add our x's is x to the negative 6. When we add up all our y's, we're going to get y to the negative 3. There's one small issue with that. What type of exponents are we dealing with up there? Negative. We can't leave them as negative. So right now those negative exponents are in the numerator. We need to rewrite them as positive. So if they start in the numerator, where do they need to go? Down to the denominator. So our final answer I'm going to put in black is going to be 1 over x to the 6th, y to the 3rd. So anytime we have those negative exponents, they need to go into their reciprocal position and then rewritten as those positive exponents. So there I'd have my final result, 1 over x to the 6th and y to the 3rd. We'll take a look then at part B. So part B, we've got a numerator with some x's and y's, and then we've got a denominator with some x's and y's. So again, we're going to use the commutative properties. So with the x's, we'll put all those together first. Let me get my new fraction bar here. So we'll get x to the negative third. Got an x to the negative 1, x to the fifth. Then with the y's, we got a y squared and a y, so we'll make that in blue. And down our denominator, we're going to have a x to the third. And we've got a y negative 7, y 4. So there we've got everything rewritten using the commutative properties. So I'll organize all my x's together. I'll organize all my y's together so that we can start using our properties. So we'll start looking at these x's here. I've got 4 x's. I'm going to use this product rule, adding those exponents to simplify all my x powers. And then same thing with my y powers. So we'll do both of those. Now again, one thing I'm noticing, just to make my life a little easier looking through this, if this is an x to the first power, then I've also got an x to the negative 1. What is 1 and negative 1 going to add to me? 0. So those are gone. So then you got a negative 3 plus 5. So negative 3 plus 5 is going to equal 2. So I have an x squared up there. Then we look at, you've got a y2 and then a y. So y2 and y2 plus 1 is going to be y to the third. Now we go down to the denominator. We've got an x to the third down there. Nothing for that to go with. And then we've got a negative 7 plus 4, which is going to give me negative 3. So then we got x squared over x to the third, y to the third over y to the negative third. And I'm going to rewrite that up above there. Put it all in black. So we got x squared over x to the third, y to the third over y to the negative third. All right? So here's where we're at. After doing that product of powers, we've got all our x's, all those exponents added up, we've got all our y's added up. Now we start looking at, we're dealing with a fraction. We got that fraction bar. When you're thinking about operations like multiplying, dividing, adding, subtracting, what does a fraction bar do? Which operation does a fraction bar represent? Add, subtract, multiply, divide. What does it represent? Morgan. Dividing. So we're dividing powers now. And when we're dividing powers, what are we going to do with these little exponents? Subtract them. So for the x's, when you have an x2 minus 3, that's going to give you x minus 1. Because I'm going to take my numerator minus my denominator. 2 minus 3 is going to give me negative 1. And then I do 3 minus the negative 3, where when you subtract the negative, what are you really actually doing? Adding. So 3 plus 3 is what the y's are going to do. So 3 plus 3 is going to be y to the 6. And we're not quite done yet. What is that x to the minus 1 going to have to do? It's going to have to go down into the denominator. So to save some space here, I'm just going to rewrite that as x to the 1. It's the reciprocal down in the denominator. So y to the 6 over x to the first would be my final result. Okay, we're just going to introduce then the power rule for exponents. On your delta map, you will see examples like these first two, and then we'll just introduce that. And then I want to give you a little bit of time here before you head out to make sure we're signed up for Go Guardian and things. So lastly, we'll take a look then at the power rule. So the last situation we could see is when you have power to a power, you are going to multiply your two exponents. So power to a power, you are going to multiply. And if maybe you had two variables raised to a power, both of those variables would get that power, x to the m, y to the n. So there would be our power rule. So down below there, like if we look at example 2 there, part B, 2x to the third power means I'm going to have a 2 to the third power, x to the third power. Down in my denominator, I'm going to have a 3 to the second power, y to the second power, x to the second power. So this 3 goes to both, this 2 goes to both. So that power to a power rule means that these variables or numbers are going to get the exponent. Both are going to get those. So that's what we're looking at with that power rule. Then we can continue. 2 to the third power is going to be 8. I've got an x to the third in the numerator, x squared in the denominator. That's going to leave me with an x. And then lastly, I've got a 9y squared down in my denominator. So those x's are going to cancel out, and we're left with 1 left in the numerator. So we'll leave it right there. So we got about 12 minutes of class. I'm going to come around and check. I just want to make sure that you can get signed up for Go Guardian if you haven't yet. I'm going to double check my list, help you with that. And then also you can start working on the Delta Math assignment. So we're just doing lesson 3, day 1 today. And tomorrow you can do day 2 on your own. That's up to you when you want to do that. But that's it for lesson 3. And then you can continue with lesson 3 tomorrow.